As a reminder, section 3.2 introduced monatomic and polyatomic ions. Monatomic ions are ions of a single atom. For example, the calcium ion. Another example, the sulfide ion. Polyatomics, on the other hand, are ions of more than a single atom and usually more than a single element. An example, the phosphate ion. Usually polyatomics are negatively charged. An exception to that is the ammonium ion. This is also a polyatomic ion, but it's positively charged. But usually, polyatomic ions in general are negatively charged. Page 95 has the polyatomics listed. In addition to that, there's a chart that may help you. Section 3.3 introduces the formulas for the ionic compounds. So an ionic compound is a combination of oppositely charged ions. So whether in its solid form or in its aqueous, meaning in water, there is always a net charge of 0. If the sodium and chloride ion combine, what ratio do they combine in? Let's take a look. If you look at your periodic table, which is in the front flap of your textbook, you can predict the ions by where they're found on the periodic table. Sodium forms a +1 ion. Chlorine, on the other hand, forms a -1 ion known as the chloride ion. If these combine, and I know that there must be a net charge of 0, how many of each of these would I need? Well, if I have +1 and if I have -1, I know that it's a 1-to-1 ratio. So it would be written NaCl. On page 96 in your textbook, you'll find figure 3.19. Sodium chloride does not exist as a discrete molecule. Rather, it exists in a crystal structure or a crystal lattice. This repeating unit right here is called a formula unit. Let's do some examples. What is the formula for an ionic compound that has the calcium ion and the chloride ion in it? First, I need to look at the charges. An easy way for me to do this is to compare the charges. I have a +2 and I have a -1. I know that they have to have a net charge of 0. So I can find the least common multiple, meaning what number, the smallest number, would these both go into? Well, the answer is 2. This is already a 2, but this I can multiply by 2 to get a -2 charge. A +2 charge and a -2 charge added together would be a net value of 0. So in this case, I know that I have 1 calcium and I have 2 chloride ions. This right here is the ionic formula. Here's my next question. If magnesium and nitrogen combine in an ionic compound, how would they combine? What ratio would they combine in? First, I need to look at the periodic table to find out what charges each of these ions would be. Magnesium forms a +2 charge. Nitrogen, on the other hand, forms a -3 charge. This is the magnesium ion, this is the nitride ion. So now, how do they combine? Let's compare the charges. Here's my +2 charge, and here's my -3 charge. Now, what is the least common multiple of these two numbers? Because remember, we have to have a net value of 0. The least common multiple of these two numbers is 6. So this will form a +6, and here we have a -6. What number do I need to multiply 3 by to get 6? I need to multiply 3 by 2 to get the value of 6. Compared to, on this side, what do I need to multiply 2 by to get 6? I need to multiply by 3. So we know that magnesium, there'll be 3 of them. So it will be magnesium 3 of those, and 2 nitrogen. There's my ionic formula. Ionic compounds that contain polyatomic ions must also have a net charge of 0. So let's do an example. If I have sodium combined with the sulfate ion, what is my formula? The sodium ion is a +1 charge. I can get that from the periodic table. If this combines with the sulfate ion, which I cannot get from my periodic table, the chart of polyatomic ions is found on page 95. If I have these combine, what is the ratio that they combine in? Let's compare charges. I have a +1 charge for my sodium, and I have a -2 charge for my sulfate. What is the least common multiple of these two numbers? The least common multiple is 2. I'm going to multiply my +1 by 2 to give me a +2 charge. This is already a -2. That would be a net charge of 0. So what does my formula look like? I have 2 sodiums and I have 1 sulfate ion. This right here is my ionic formula. Here's another example. What is the formula for a calcium ion and a nitrate ion? Calcium I can find on the periodic table. That's a +2 charge. What about the nitrate? Nitrate is a polyatomic ion, so look on page 95. That is NO3 -1. I compare my charges. I have a +2 here, and I have a -1 here. What is the least common multiple? The least common multiple is 2. I multiply this by 2 to give me a -2 value. Comparing these, that is a net 0 charge. So what is my chemical formula? I have 1 calcium and I have 2 nitrates. How am I going to write 2 of those? I'm going to put a parentheses and put 2 right there. That is my chemical formula for calcium nitrate. Let's try one more example. Barium and phosphate. Barium forms what type of ion? Look at the periodic table. It forms a +2 ion. Phosphate, on the other hand, is a polyatomic ion. Let's compare charges. Barium has a +2 charge. Phosphate, on the other hand, has a -3 charge. What is my least common multiple of 2 and 3? My least common multiple of 2 and 3 is 6. So what am I going to multiply 2 by to get +6? I'm going to multiply +2 by 3 to get +6. What am I going to multiply -3 by to get a -6? I'm going to multiply that by 2 to get a -6 value. These must be opposite in charge, but equal. I must have a net value of 0. So let's write the formula. I'm going to have 3 barium, and I'm going to have 2 phosphate. How do I write 2 of these? Again, I write my parentheses, and I put a 2 down there. That represents 2 phosphates. This right here is my chemical formula. In section 3.3, we just learned how to write the formulas for ionic compounds. Next, you're prepared to name ionic compounds in section 3.4.